Hello algebra students, this is Coach Sharp. Today's video topic is writing functions, unit 4.4, and hopefully after this video and completing your guided notes and doing some other work through the examples and things like that, you'll be able to construct a linear function given different sets of data. Maybe an arithmetic sequence, maybe a graph, maybe just a verbal description, some ordered pairs, or maybe even a table or a T-chart. So a little bit of a review to start with. If we're given a chart such as this one, and we have our x's, we call that our input, and we have our equation, f of x is equal to 3x plus 1, and I guess I should be more specific, more technical. If it has f of x right here, then it's a function, not an equation, but that's just terminology. Then we need to complete the y, or the output column, in order to be able to write our equation, or to be able to graph, or whatever else they ask us to do. So again, we're going to take each of our inputs, and we're going to substitute those inputs into, as they call it, the function or the process or the equation, and then get our output values. So let's do that. If we substitute 1 in for x to complete this first row, then placing 1 in for x here, I get f of x, f of 1 rather, because we're substituting 1, is equal to 3 times 1 plus 1, and so that's going to give me 4. Filling out the rest of the chart, f of 2 is going to give me 3 times 2 plus 1, or 7. f of 3 is going to give me 3 times 3 plus 1, or 10. f of 4, 3 times 4 plus 1 is 13, and f of 5, 3 times 5 plus 1, 16. At the bottom of the screen there, it says the inputs are the variables that can be controlled. In other words, you get to choose all of these. Now, I guess technically at this point you didn't, because they were already in that chart, but you can choose what you input for x. The output, or our y's over here, are dependent, or they depend on the things that we picked with our input. So we input, put it in our function, our process, our equation, and we get the outputs. So going from that to some definitions here, remember that the independent variable, we get to choose those independent variables. So that was our x in that last screen. They can be changed, they can be controlled, they're all up to us. Those are independent. We choose what goes in there. The dependent variable are denoted as the y's, the outputs, and they are dependent because they depend on what you choose in the independent variable. Always the dependent variable, as we said, was x, so that's the horizontal axis. The independent is y, that's the vertical axis. Function data, the data that we use, our x's and our y's, our independents, our dependents, can be found in a variety of forms. They can be in ordered pairs. If they're in ordered pairs, then the first space is the x, second space is the y. Remember from previous lesson, we called these the domain. We called these the range, so it might even be given as that. We can have tables, we can have a graph that we had to get the ordered pairs from the graph. We could be given a description of some sort, and we could also have an arithmetic sequence. Okay, so constructing a function rule. To construct a function rule, we're going to look for a pattern that changes the input, the x's, into the f of x or the y. So in other words, we want to know, what can we do to this that equals, that would equal this. So, you know, you can do a kind of a guess and check thing. Maybe we multiply that by 5 to equal 5. And then we would see if that worked. Is 2 times 5 6? No. So times 5 didn't work. So let's try something else. What if we add 4? 1 plus 4 equals 5. 2 plus 4 equals 6. 3 plus 4 equals 7. 4 plus 4 equals 8. It worked. So that means that our rule, if we were doing a function, and we're going to do f of x is equal to our first column, x plus 4. So I guess I should fill in down here, f of x equals x plus 4.